The McLaren F1 is a sports car designed and manufactured by McLaren Automotive. Originally a concept conceived by Gordon Murray, he convinced Ron Dennis to back the project and engaged Peter Stevens to design the exterior and interior of the car. On March 31, 1998, it set the record for the world's fastest production car, reaching 231 mph with the rev limiter enabled, and 240 mph with the rev limiter removed. The car features numerous proprietary designs and technologies. It is lighter and has a more streamlined structure than many modern sports cars, despite having one seat more than most similar sports cars, with the driver's seat located in the center of two passenger seating positions, providing driver visibility superior to that of a conventional seating layout. It features a powerful engine and is somewhat track-oriented, but not to the degree that it compromises everyday usability and comfort. It was conceived as an exercise in creating what its designers hoped would be considered the ultimate road car. Despite not having been designed as a track machine, a modified race car edition of the vehicle won several races, including the 24 Hours of Le Mans in 1995, where it faced purpose-built prototype race cars. Production began in 1992 and ended in 1998. In all, 106 cars were manufactured, with some variations in the design. In 1994, the British car magazine Autocar stated in a road test regarding the F1, "The McLaren F1 is the finest driving machine yet built for the public road," and that the F1 will be remembered as one of the great events in the history of the car, and it may possibly be the fastest production road car the world will ever see. In August 2013, at the Pebble Beach Concours d'Elegance, Gooding & Company auctioned off chassis 066 for a record sale price of $8.47 million. Design and implementation. Chief Engineer Gordon Murray's design concept was a common one among designers of high-performance cars, low weight and high power. This was achieved through use of high-tech and expensive materials such as carbon fiber, titanium, gold, magnesium and Kevlar. The F1 was the first production car to use a carbon fiber monocoque chassis. Gordon Murray had been thinking of a three-seat sports car since his youth. When Murray was waiting for a flight home from the fateful Italian Grand Prix in 1988, he drew a sketch of a three-seater sports car and proposed it to Ron Dennis. He pitched the idea of creating the ultimate road car, a concept that would be heavily influenced by the company's Formula One experience and technology and thus reflect that skill and knowledge through the McLaren F1. Murray declared that during this time, "We were able to visit with Ayrton Senna and Honda's Tokaji Research Center." The visit related to the fact that at the time, McLaren's F1 Grand Prix cars were using Honda engines. "Although it's true I had thought it would have been better to put a larger engine, the moment I drove the Honda NSX, all the benchmark cars are Ferrari, Porsche, Lamborghini I had been using as references in the development of my car vanished from my mind. Of course the car we would create, the McLaren F1, needed to be faster than the NSX, but the NSX's ride quality and handling would become our new design target." Being a fan of Honda engines, I later went to Honda's Tokaji Research Center on 2 occasions and requested that they consider building for the McLaren F1 a 4.5-liter V12 or V14. I tried to persuade them, but in the end could not convince them to do it, and the McLaren F1 ended up equipped with a BMW engine. Later, a pair of Ultima Mk3 kit cars, chassis numbers 12 and 13, Albert, and Edward, the last two Mk3s, were used as mules to test various components and concepts before the first cars were built. Number 12 was used to test the gearbox with a 7.4-liter Chevrolet V8, plus various other components such as the seats and the brakes. Number 13 was the test of the V12, plus exhaust and cooling system. When McLaren was done with the cars they destroyed both of them to keep away the specialist magazines and because they did not want the car to be associated with kit cars. The car was first unveiled at a launch show, May 28, 1992, at the Sporting Club in Monaco. The production version remained the same as the original prototype except for the wing mirror which, on the XP1, was mounted at the top of the A-pillar. This car was deemed not road legal as it had no indicators at the front. McLaren was forced to make changes on the car as a result. The original wing mirrors also incorporated a pair of indicators which other car manufacturers would adopt several years later. The car's safety levels were first proved when during a testing in Namibia in April 1993, a test driver wearing just shorts and t-shirt hit a rock and rolled the first prototype car several times. The driver managed to escape unscathed. Later in the year, the second prototype was especially built for crash testing and passed with the front wheel arch untouched. Engine history. Gordon Murray insisted that the engine for this car be naturally aspirated to increase reliability and driver control. Turbochargers and superchargers increase power, but they increase complexity and can decrease reliability, as well as introducing an additional aspect of latency and loss of feedback. The ability of the driver to maintain maximum control of the engine is thus decreased. Murray initially approached Honda for a power plant with 550 bhp, 600 Nm block length and a total weight of 250 kg. It should be derived from the Formula One power plant in the then dominating McLaren Honda cars. When Honda refused, Isuzu, then planning an entry into Formula One, had a 3.5-litre V12 engine being tested in a Lotus chassis. The company was very interested in having the engine fitted into the F1. However, the designers wanted an engine with a proven design and a racing pedigree. Specifications. In the end, BMW took an interest, and the motorsport division BMW M, headed by engine expert Paul Rush, designed and built Murray a 6.1 L60-degree V12 engine called the BMW S70/2. At 627 HP and 266 kg, the BMW engine ended up 14% more powerful and 16 kg heavier than Gordon Murray's original specifications, with the same block length. It has an aluminium alloy block and heads, with 86 mm x 87 mm bore-stroke, quad overhead camshafts with variable valve timing for maximum flexibility of control over the 4 valves per cylinder, and a chain drive for the camshafts for maximum reliability. The engine uses a dry sump oil lubrication system. The carbon fiber body panels and monocoque required significant heat insulation in the engine compartment, so Murray's solution was to line the engine bay with a highly efficient heat reflector, gold foil. Approximately 16 g of gold was used in each car. The road version used a compression ratio of 11:1 to produce 627 lhp at 7400 rpms and torque output of 480 lb-ft at 5600 rpms. The engine has a readline rev limiter set at 7500 rpms. In contrast to raw engine power, a car's power-to-weight ratio is a better method of quantifying acceleration performance than the peak output of the vehicle's power plant. The standard F1 achieves 550 horsepower per ton, or just 3.6 pound per horsepower. The cam carriers, covers, oil sump, dry sump, and housings for the camshaft control are made of magnesium castings. The intake control features 12 individual butterfly valves, and the exhaust system has 4 Inconel catalysts with individual lambda Sundian controls. The camshafts are continuously variable for increased performance, using a system very closely based on BMW's VANOS variable timing system for the BMW M3. It is a hydraulically actuated phasing mechanism which retards the inlet cam relative to the exhaust cam at low revs, which reduces the valve overlap and provides for increased idle stability and increased low-speed torque. At higher RPM, the valve overlap is increased by computer control to 42 degrees for increased airflow into the cylinders and thus increased performance. To allow the fuel to atomize fully, the engine uses 2 Lucas injectors per cylinder, with the first injector located close to the inlet valve operating at low engine RPM while the second is located higher up the inlet tract operating at higher RPM. The dynamic transition between the two devices is controlled by the engine computer. Each cylinder has its own miniature ignition coil. The closed-loop fuel injection is sequential. The engine has no NOx sensor, as the predicted combustion conditions would not cause this to be a problem. The pistons are forged in aluminium. Every cylinder bore has a nickel coating giving it a high degree of wear resistance. From 1998 to 2000, the Le Mans Euro-winning BMW V12 LM sports car used a similar S70/2 engine. The engine was given a short development time, causing the BMW design team to use only trusted technology from prior design and implementation experience. The engine does not use titanium valves or connecting rods. Variable intake geometry was considered but rejected on grounds of unnecessary complication. As for fuel consumption, the engine achieves on average 15.2 mpg, at worst 9.3 mpg and at best 23.4 mpg. Chassis and body: the McLaren F1 was the first production road car to use a complete carbon fiber reinforced plastic monocoque chassis structure. Aluminium and magnesium were used for attachment points for the suspension system, inserted directly into the CFRP. The car features a central driving position. The driver's seat is located in the middle, ahead of the fuel tank and ahead of the engine, with a passenger seat slightly behind and on each side. The doors on the vehicle move up and out when opened, and are thus of the butterfly type. The engine produces high temperatures under full application and thus causes a high temperature variation in the engine bay from no operation to normal and full operation. CFRP becomes mechanically stressed over time from high heat transfer effects and thus the engine bay was not constructed from CFRP. Aerodynamics: the overall drag coefficient on the standard McLaren F1 is 0.32, compared with 0.36 for the faster Bugatti Veyron, and 0.357 for the SSC Ultimate Aero TT, which was the fastest production car from 2007 to 2010. The vehicle's frontal area is 1.79 square meters, and the ZRCD figure is 0.57. Because the machine features active aerodynamics, these are the figures presented in the most streamlined configuration. The normal McLaren F1 features no wings to produce downforce. However, the overall design of the underbody of the McLaren F1 in addition to a rear diffuser exploits ground effect to improve downforce, which is increased through the use of two electric Kevlar fans to further decrease the pressure under the car. A high downforce mode can be turned on and off by the driver. At the top of the vehicle, there is an air intake to direct high-pressure air to the engine with a low-pressure exit point at the top of the very rear. Under each door is a small air intake to provide cooling for the oil tank and some of the electronics. The airflow created by the electric fans not only increase downforce, but the airflow that is created is further exploited through design, by being directed through the engine bay to provide additional cooling for the engine and the ECU. At the front, there are ducts assisted by a Kevlar electric suction fan for cooling of the front brakes. There is a small dynamic rear spoiler on the tail of the vehicle, which will adjust dynamically and automatically attempt to balance the center of gravity of the car under braking which will be shifted forward when the brakes are applied. Upon activation of the spoiler, a high-pressure zone is created in front of the flap, and this high-pressure zone is exploited. Euro 2 air intakes are revealed upon application that will allow the high-pressure airflow to enter ducts that route air to aid in cooling the rear brakes. The spoiler increases the overall drag coefficient from 0.32 to 0.39 and is activated at speeds equal to or above 40 mph by brake line pressure. Suspension: Steve Randall, who was the car's dynamicist, was appointed responsible for the design of the suspension system of the McLaren F1 machine. It was decided that the ride should be comfortable yet performance-oriented, but not as stiff and low as that of a true track machine, as that would imply reduction in practical use and comfort as well as increasing noise and vibration, which would be a contradictory design choice in relation to the former set premise. The goal of creating the ultimate road car. From inception, the design of the F1 vehicle had strong focus on centering the mass of the car as near the middle as possible by extensive manipulation of placement of, inter alia, the engine, fuel and driver, allowing for a low polar moment of inertia and yaw. The F1 has 42% of its weight at the front and 58% at the rear. This figure changes less than 1% with the fuel load. The distance between the mass centroid of the car and the suspension roll center were designed to be the same front and rear to avoid unwanted weight transfer effects. Computer-controlled dynamic suspension were considered but not applied due to the inherent increase in weight, increased complexity and loss of predictability of the vehicle. Damper and spring specifications: 90 on bump, 80 on rebound with bounce frequency at 1.43 Hz at front and 1.80 Hz at the rear. Despite being sports-oriented, these figures imply a soft ride and inherently decreased track performance. As can be seen from the McLaren F1 LM, McLaren F1 GT-RAL, the track performance potential is much higher than that in the stock F1 due to fact that car should be comfortable and usable in everyday conditions. The suspension is a double wishbone system with an unusual design. Longitudinal wheel compliance is included without loss of wheel control, which allows the wheel to travel backwards when it hits a bump, increasing the comfort of the ride. Caster windoff at the front during braking is handled by McLaren's proprietary ground plane shear center. The wishbones on either side in the subframe are fixed in rigid plane bearings and connected to the body by 4 independent bushes which are 25 times more stiff radially than axially. This solution provides for a caster windoff measured to 1.02 degrees per g of braking deceleration. Compare the Honda NSX at 2.91 degrees per g, the Porsche 928S at 3.60 degrees per g and the Jaguar XJ6 at 4.30 degrees per g respectively. The difference in toe and camber values are also of very small under lateral force application. Inclined shear axis is used at the rear of the machine, provides measurements of 0.04 degrees per g of change in toe and under braking and 0.08 degrees per g of toe out under traction. When developing the suspension system, the facility of electrohydraulic kinematics and compliance at Anthony Best Dynamics was employed to measure the performance of the suspension on a Jaguar XJ16, a Porsche 928S and a Honda NSX to use as references. Steering knuckles and the top wishbone bell crank are also specially manufactured in an aluminium alloy. The wishbones are machined from a solid aluminium alloy with CNC machines. Tires: the McLaren F1 uses 235/45 ZR17 front tires and 315/45 ZR17 rear tires. These are specially designed and developed solely for the McLaren F1 by Goodyear and Michelin. The tires are mounted on 17 by 9 inch and 17 by 11.5 inch cast magnesium wheels, protected by a tough protective paint. The 5-spoke wheels are secured with magnesium retention pins. The turning circle from curb to curb is 13 am, allowing the driver 2.8 turns from lock to lock. Brakes: the F1 features unassisted, vented and cross-drilled brake discs made by Brembo. Front size is 332 ohm and at the rear 305 ohm. The calipers are all 4-pot, opposed piston types, and are made of aluminium. The rear brake calipers do not feature any handbrake functionality. However, there is a mechanically actuated, fist-type caliper which is computer-controlled and thus serves as a handbrake. To increase caliper stiffness, the calipers are machined from one single solid piece. Pedal travel is slightly over 1 inch. Activation of the rear spoiler will allow the air pressure generated at the back of the vehicle to force air into the cooling ducts located at either end of the spoiler, which become uncovered upon application of it. Servo-assisted ABS brakes were ruled out as they would imply increased mass, complexity and reduced brake feel. However, at the cost of increasing the required skill of the driver. Gordon Murray attempted to utilize carbon brakes for the F1, but found the technology not mature enough at the time. With one of the major culprits being that of a proportional relationship between brake disc temperature and friction that is stopping power thus resulting in relatively poor brake performance without an initial warm-up of the brakes before use. Since carbon brakes have a more simplified application envelope in pure racing environments, this allows for the racing edition of the machine, the F1 GT-R, to feature ceramic carbon brakes. Gearbox and powertrain: the standard McLaren F1 has a transverse 6-speed manual gearbox with an AP carbon triple-plate clutch contained in an aluminium housing. The second-generation GT-R edition has a magnesium housing. Both the standard edition and the McLaren F1 LM have the following gear ratios: 3.231, 2.191, 1.711, 1.391, 1.161, 0.931, with a final drive of 2.371, the final gear is offset from the side of the clutch. The gearbox is proprietary and was developed by Weissman. The Torsen LSD has a 40% lock. The McLaren F1 has an aluminium flywheel that has only the dimensions and mass absolutely needed to allow the torque from the engine to be transmitted. This is done in order to decrease rotational inertia and increase responsiveness of the system, resulting in faster gear changes and better throttle feedback. This is possible due to the F1 engine lacking secondary vibrational couples and featuring a torsional vibration damper by BMW. Interior and equipment. Standard equipment on the stock McLaren F1 includes full cabin air conditioning, a rarity on most sports cars, and a system design which Murray again credited to the Honda NSX, a car he had owned and driven himself for 7 years without, according to the official F1 website, ever needing to change the AC automatic setting. Further comfort features included Securite electric defrost demist windscreen and side glass, electric window lifts, remote central locking, Kenwood 10-disc CD stereo system, cabin access release for opening panels, cabin storage compartment, 4-lamp high-performance headlight system, rear fog and reversing lights, courtesy lights in all compartments, map reading lights and a gold-plated Facon titanium toolkit and first aid kit. In addition, tailored, proprietary luggage bags specially designed to fit the vehicle's carpeted storage compartments, including a tailored golf bag, were standard equipment. Airbags are not present in the car. Each customer was given a special edition TAG Her 6000 chronometer wristwatch with its serial number scripted below the center stem. All features of the F1 were, according to Gordon Murray, obsessed over including the interior. The metal plates fitted to improve aesthetics of the cockpit are claimed to be 0.20 of an inch thick to save weight. The driver's seat of the McLaren F1 is custom fitted to the specifications desired by the customer for optimal fit and comfort. The seats are handmade from CFRP and covered in light Connolly leather. By design, the F1 steering column cannot be adjusted. However, prior to production each customer specifies the exact preferred position of the steering wheel and thus the steering column is tailored by default to those owner settings. The same holds true for the pedals, which are not adjustable after the car has left the factory, but are tailored to each specific customer. During its pre-production stage, McLaren commissioned Kenwood, the team's supplier of radio equipment, to create a lightweight car audio system for the car. Kenwood, between 1992 and 1998, used the F1 to promote its products in print advertisements, calendars and brochure covers. Each car's audio system was especially designed to tailor to an individual's listening taste, however radio was omitted because Murray never listened to the radio. Every standard F1 also has a modem which allows customer care to remotely fetch information from the ECU of the car in order to assist the customer in the event of a mechanical vehicle failure. Purchase and maintenance: only 106 cars were manufactured, 64 of which were the standard street version, 5 were LMs, 3 were long-tail road cars, 5 prototypes, 28 race cars and 1 LM prototype. Production began in 1992 and ended in 1998. At the time of production each machine took around 3.5 months to make. Although production stopped in 1998, McLaren still maintains an extensive support and service network for the F1. There are 8 authorized service centers throughout the world, and McLaren will on occasion fly a specialized technician to the owner of the car or the service center. All of the technicians have undergone dedicated training in service of the McLaren F1. In cases where major structural damage has occurred, the car can be returned to McLaren directly for repair. Performance: the F1 remains one of the fastest production cars ever made. As of July 2013 it is succeeded by very few cars, including the Koenigsegg Agera, the Bugatti Veyron, the SSC Ultimate Aero TT, the Hennessy Venom GT and the Bugatti Veyron Supersport. However, all of the superior top-speed machines use forced induction to reach their respective top speeds, whereas the McLaren F1 is naturally aspirated. Acceleration, 0-30 mph, 1.7s, 0-60 mph, 3.2s, 0-100 mph, 6.3s, 0-124.28 mph, 9.4s, 0-150 mph, 12.8s, 0-200 mph, 28s, 30 mph-50 mph, 1.8s, using 3rd/4th gear, 30 mph-70 mph, 2.1s, using 3rd/4th gear, 40 mph-60 mph, 2.3s, using 4th/5th gear, 50 mph-70 mph, 2.8s, using 5th gear, 180 mph-200 mph, 7.6s, using 6th gear, 0-400 am, 11.1s at 138 mph, 0-1000 am, 19.6s at 177 mph, track tests, Tsukuba circuit, time trial, 104.62 on a hot lap. Millbrook Proving Ground in Bedfordshire, 2-mile banked circuit, top speed test, an average speed of 195.3 mph, with a maximum speed of 200.8 mph. Myra, 2.82-mile banked circuit, top speed test, an average speed of 168 mph, with a maximum speed of 196.2 mph. Record claims. The title of world's fastest production road car is constantly in contention, especially because the term production car is not well defined. The McLaren F1 has a top speed of 240 mph, restricted by the rev limiter at 7,500 rpms. The true top speed of the McLaren F1 was reached in April 1998 by the 5-year-old XP5 prototype. Andy Wallace piloted it down the 9 km straight at Volkswagen's test track in Erlesien, Germany, setting a new world record of 243 mph at 8,300 rpms. As Mario Andretti noted in a comparison test, the F1 is fully capable of pulling a 7th gear, thus with a higher gear ratio or a 7th gear the McLaren F1 would probably be able to reach an even greater top speed something which can also be observed by noticing that the top speed was reached at 7,800 rpms while the peak power is reached at 7,400 rpms. Variants, the McLaren F1 road car, of which 64 were originally sold, saw several different modifications over its production span which were badged as different models. Of the road versions, 21 are reportedly in the United States. One of the completed street cars remained in McLaren's London showroom for a decade before being offered for sale as new in 2004. This vehicle became the 65th McLaren F1 sold. The showroom, which was on London's luxurious Park Lane, has since closed. The company maintains a database to match up prospective sellers and buyers of the cars. Prototypes. Prior to the sale of the first McLaren F1s, 5 prototypes were built, carrying the numbers XP1 through XP5. These cars carried minor subtle differences between each other as well as between the production road cars. XP1 was the first publicly unveiled car, and later destroyed in the accident in Namibia. XP2 was used for crash testing and also destroyed. Neither was ever painted. XP3 did durability testing, XP4 stress tested the gearbox system and XP5 was a publicity car, all owned by McLaren. They were also used for publicity shots and tested by reporters. All were painted a different color, and each was able to be distinguished by its chassis code painted on the side rocker panel. XP3 is still owned by Murray. XP4 was seen by many viewers of Top Gear when reviewed by Tiffany Adele in the mid-1990s, while XP5 went on to be used in McLaren's famous top speed run. Ameritech, the American model of the McLaren F1, the Ameritech McLaren F1 is a modified standard McLaren F1 to meet the U.S. regulations. To comply with said regulations the car had to meet stricter emission requirements which increase the weight and also reduce the power somewhat. Due to a lack of airbags for the passengers, the Ameritech edition only has the single driver seat in the middle. F1 LM only 5 McLaren F1 LM cars were built in honor of the 5 McLaren F1 GTRs which finished the 1995 24 Hours of Le Mans, including taking the overall win. The weight was reduced by approximately 75 kg over that of original, through the removal of various pieces of trim and use of optional equipment. The car also had a different transaxle, various aerodynamic modifications, specially designed 18-inch magnesium alloy wheels and upgraded gearbox. The F1 LM used the same engine as the 1995 F1 GTR, but without race-mandated restrictors, to produce 680 HP. It had a top speed of 225 mph, which is less than the standard version because of added aerodynamic drag, despite identical gear ratios. The LM is 76 kg lighter than the stock F1 a total mass of 1062 kg achieved by having no interior noise suppression, no audio system, a stripped-down base interior, no fan-assisted ground effect and no dynamic rear wing. In the place of the small dynamic rear wing there is a considerably larger, fixed CFRP rear wing mounted on the back of the vehicle. The LM has the following performance figures: peak torque of 705 Nm at 4,500 rpm and peak power of 680 PS at 7,800 rpm, it has a readline at 8,500 rpm. The total weight of 1,062 kg gives the car a 110.16 bhp per litre ratio. Officially recorded acceleration times are 0-60 mph in 3.9 seconds and 0-100 mph in 6.7 seconds. The LM was once the holder of the 0-100-0 mph record, which it completed in 11.5 seconds when driven by Andy Wallace at the disused airbase RAF Alconbury in Cambridgeshire. The F1 LMs can be identified by their papaya orange paint. The F1 LMs were painted in this color in memory of, and tribute to, Bruce McLaren, whose race color was papaya orange. Although only 5 F1 LMs were sold, a sixth chassis exists in the form of XP1 LM, the prototype for modifications to the existing F1 to form the new F1 LM. This car is also painted papaya orange and is retained by McLaren. This car, reportedly worth $4 a million, was promised in 2008 by McLaren CEO Ron Dennis to his driver Lewis Hamilton if he should win 2 Formula One World Championship titles. Hamilton has since won 1 World Championship. F1 GT, the final incarnation of the road car, the F1 GT was meant as a homologation special. With increased competition from homologated sports cars from Porsche and Mercedes-Benz in the former BPA Global GT Series and new FIA GT Championship, McLaren required extensive modification to the F1 GTR in order to remain competitive. These modifications were so vast that McLaren would be required to build a production road-legal car on which to base the new race cars. The F1 GT featured the same extended rear bodywork as the GTRs for increased downforce and reduced drag, yet lacked the rear wing that had been seen on the F1 LM. The downforce generated by the longer tail was found to be sufficient to not require the wing. The front end was also similar to the racing car, with extra louvers and the wheel arches widened to fit larger wheels. The interior was modified and a racing steering wheel was included in place of the standard unit. The F1 GTs were built from standard F1 road car chassis, retaining their production numbers. The prototype GT, known as XP-GT, was F1 chassis number 056, and is still kept by McLaren. The company technically only needed to build 1 car and did not even have to sell it. However, demand from customers drove McLaren to build 2 production versions that were sold. The customer F1 GTs were chassis number 054 and number 058. Motorsports. Following its initial launch as a road car, motorsports teams convinced McLaren to build racing versions of the F1 to compete in international series. 3 different versions of the race car were developed from 1995 to 1997. Many F1 GTRs, after the cars were no longer eligible in international racing series, were converted to street use. By adding mufflers, passenger seats, adjusting the suspension for more ground clearance for public streets, and removing the air restrictors, the cars were able to be registered for road use. F1 GTR 1995. Built at the request of race teams, such as those owned by Ray Bellman Thomas BSCHER, in order to compete in the BPR Global GT Series. The McLaren F1 GTR was a custom-built race car which introduced a modified engine management system that increased power output to Euro. However, air restrictors mandated by racing regulations reduced the power back to 600 HP at 7,500 rpm. The car's extensive modifications included changes to body panels, suspension, aerodynamics and the interior. The F1 GTR would go on to take its greatest achievement with first, third, fourth, fifth, and 13th places in the 1995 24 Hours of Le Mans, beating out custom-built prototype sports cars. In total, 9 F1 GTRs would be built for 1995. F1 GTR 1996. To follow up on the success of the F1 GTR into 1996, McLaren further developed the 1995 model, leading to a size increase but weight decrease. 9 more F1 GTRs were built to 1996 spec, while some 1995 cars were still campaigned by privateers. F1 GTR 1996 chassis number 14 is notable as being the first non-Japanese car to win a race in the All-Japan Grand Touring Car Championship. The car was driven by David Brabham and John Nielsen. The weight was reduced with around 100 kg from the 1995 GTR edition and the engine was kept detuned at 600 HP to comply with racing regulations. F1 GTR 1997. With the F1 GT homologated, McLaren could now develop the F1 GTR for the 1997 season. Weight was further reduced and a sequential gearbox was added. The engine was slightly de-stroked to 6.0 L instead of the previous 6.1 L. Due to the heavily modified bodywork, the F1 GTR 1997 is often referred to as the Longtail thanks to the rear bodywork being extended to increase rear downforce. A total of 10 F1 GTR 1997 models were built. The weight was reduced to a total of 910 kg. References. Driving Ambition, the official inside story of the McLaren F1, Haymarket Magazines Limited 1994, F1 a Euro McLaren's Road Car, F1 a Euro McLaren's Road Car, an Autocar and Motor Book, McLaren F1 GTR LM Sports Cars Performance Portfolio, the fastest cars from around the world, external links, video of the McLaren F1 XP5 prototype tested in top speed, official McLaren Automotive website, McLaren F1 in detail at Octane magazine. Exclusive, the cars of the McLaren F1 Tour at Bold Ride.